In this problem, we're going to find the inverse of the 3x3 matrix shown here. So there are formulas for producing the inverses of 3x3 and 4x4 matrices. But I think it can be a bit faster to just do row reduction. So the idea is that we're going to take our matrix A and we're going to super augment with the identity matrix. All right. Then we're going to use row reduction until the left-hand side is equal to the identity. On the right-hand side, what will remain is our matrix A inverse. So we start with the following augmented matrix. We have A on the left, and we have the identity matrix on the right. Okay, and we're just going to follow normal row reduction. So we're going to start by subtracting 2 copies of row 1 from row 3. So row 3 is going to turn into row 3 minus 2 row 1. Okay, and we do this to both sides of the augment. So our first entry is going to turn into a 0, and then we have a 1, and then negative 2. We get negative 2, 0, 1. Okay. Next up, rather than working with fractions, we're going to switch row 2 and row 3, just so that we can have a 1 in our pivot position. So let's say we're going to switch row 3 and row 2. Okay, now we have a 1 in this position. We're going to clear out underneath it. So we're going to subtract 2 copies of row 2 from row 3. Okay, so our last row becomes 0, 0. So we're going to have 1 minus 2 times negative 2 is 5. And then 0 minus 2 times negative 2 is going to be 4, 1, and negative 2. Okay, we're doing great. Next, we need to start moving upwards, doing some backwards work. So let's start by changing this 5 to a 1. Okay, so our bottom row becomes 0, 0, 1, 4/5, 1/5, negative 2/5. And we are ready to start clearing out entries that are above this one. Okay, so we're going to add in copies of this third row above. It's not the most fun thing, but it's not too bad either. Okay, so we're going to do 2 things. We're going to take row 2 plus 2 copies of row 3, and we're going to look at row 1 minus 3 copies of row 3. Okay. So we've got 1, 2, 0. That one's easy. And then we want 3 copies of 4/5, so to subtract 1. So this is going to be 1 minus 12/5. So 5 minus 12/5 is going to be negative 7/5. Minus 3 copies of 1/5 is going to be minus 3/5. And then plus 6 copies, we have 6/5. Row 2 we're going to replace with row 2 plus 2 row 3. So this is going to be 0, 1, 0. -2 plus 8/5. -2 plus 8/5 is going to be -10 plus 8/5. So that'll be -2/5. 0 plus 2 times 1/5 is going to be 2/5. And then 1 plus 2 times -2/5 is going to be 1 plus -4/5 or 1/5. Okay, and we keep the bottom row. So scrap paper is handy to have around for these. All right, just one more entry to do. We're going to clear out that remaining 2, this 2 here. We're going to subtract 2 copies of row 2 from row 1. All right, so let's record our easy row. This is the bottom 2. We've got 0, 0, 1, 4/5, 1/5, -2/5. And 0, 1, 0, -2/5, 2/5, and 1/5. All right. And for this final row, we're going to do this workout a little bit more. So we have row 1, so we have -7/5 minus 2 times -2/5. Okay, so -7 plus 4 is going to be -3/5. Okay, we've got, if we look at this entry, we've got -3/5 minus 2 times 2/5. Okay, so this is going to be -7/5. And for entry 3 here, we have 6/5 minus 2 times 1/5, or 4/5. So when you're working on these problems, there's no shame in writing out your arithmetic. There's a lot to keep track of. And so our final answer is this matrix here. We might write it a little bit more simply by factoring out a 1/5, but this is it. We're all done.